In our session today, we're going to be looking at a very interesting area of application involving the microcomputer and the basic programming language. We're going to look at the whole area of probability and how we represent a probabilistic event within the framework of the programming language. How do we show the element of chance or uncertainty and represent it in actual programming instructions? To do this, we're going to introduce two new keywords that will be part of the programs we write today. The first keyword has the abbreviation INT, and when we use it in an equation such as this, what it does is act on whatever result is included in parentheses and remove the fractional part. It makes an integer out of any argument that we reference it to. So that's the first built-in function. The second built-in function is RND, and this is known as a random number generator. A random number generator. Conceptually, what's it doing? It's drawing numbers out of a hat for us. We can even view it as a turning wheel, a carnival wheel, that has the numbers 1 to 100 on it. And where it stops is really up to the laws of probability. In a fair wheel, every number having an equal chance to be selected. So when we place this built-in function into an equation, the programming language is going to, in effect, dip down into a hat and pull out a random value for us. Now, it's going to do this in a way that will give us the reply in an interval from 0.000 to 0.99999. In other words, the random value that it draws from its procedure is going to be a fraction. So we're going to develop a technique, a formula, that's going to allow us to control how many numbers are in the hat. Suppose I want to draw a number out of a hat, and I want the hat to contain 10 unique numbers, numbers 1 through 10. I'm going to come up with an expression of this type. Whereby I multiply the fraction by 10, and after the multiplication, I drop off the fractional part. Now, if you actually work these out with a few examples, you'll find the only possible answers that will come out of this expression are the numbers 0 through 9. So if I want to further adjust this formula to get rid of the number 0, I'll add 1 to the expression. So now that formula will randomly produce for me the numbers in the range of 1 to 10. That's going to be the built-in functions we're going to use. Let's go to the microcomputer and actually demonstrate this in some programs. The first program, let's write a program that will actually toss a coin. We'll simulate the tossing of a coin using the random number generator from the basic programming language. Our first statement, remark statement, toss a coin. Statement 20. Here's our probabilistic statement. We'll coin a name, coin if you will, and have that equal to the formula that we've just discussed. The integer function, and then in parentheses, the multiplier, in this case, is going to reflect the number of possibilities or outcomes in this event. Well, a coin being tossed will have two possibilities. So our pre-multiplier is 2 times the random number generator. And in the case of this particular microcomputer, the random number generator requires us to carry a positive value along with it. What this does is it has the effect of giving us different sequences of random numbers every time we call upon the random number generator. So the main thing here is that the pre-multiplier, 2 outcomes, times the fractional random variate, and then let's add 1 so that the results that are possible to derive from this are either the numbers 1 or 2, where the number 1 will stand for the coin coming up heads, and the number 2 will stand for the coin coming up tails. So statement 20, in effect, we're flipping the coin right in statement 20. Statement 30, we're going to ask a question via our if keyword. If the coin that we just flipped is equal to 1, then let's print heads as the outcome. Statement 40 will take care of the second possibility. If the coin we just flipped has the value 2 that's come up as a result of our formula, then we want to print tails. In statement 50, let's begin to use our input keyword a little more and ask the person if they want another try. So I'm going to actually use an expanded form of the input statement where I can include a message right as part of the input statement to the person. And then await the person's response. I'll invent the name $, as a character string, non-numeric response from the person. So the input, it's going to await the person to enter the information. It's going to give him a little prompt there, the word another. You want another flip of the coin. In statement 60, we'll check the response coming in from the person. If $, equals yes, then go back to the top of the program. Start the program all over again. So that statement 60 reads that if the $, the response itself from the person is affirmative, is yes, then go back to statement numbered 10.